In this video, we're going to look at how to create a motion diagram. When you finish this video, you should be able to create your own motion diagrams. Now, a motion diagram is one way to represent motion. Another way to represent motion would be various kinds of graphs. But a representation is some kind of picture of what's going on. And so a motion diagram is a picture or a way to represent a particular motion. So we're going to need a motion to start with, to think about. Let's consider motion of a person walking a steady pace. So the person maybe starts over here and walks a nice steady pace all the way across the screen. Now let's imagine that person carrying a bucket of paint, and as they walk, that paint has a hole in the bottom and the bucket leaks. Then when the person starts over here, there's a little drop that they make, and a little while later, maybe if it's every second, and another little drop, and another little drop, and another little drop, and another little drop, 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 drop. Okay, so the paint spots on the floor leave a record of their motion, and if we translate that onto paper or captured that, took a picture of that, then we would get what's called a motion diagram. Now we can add to our motion diagram some arrows which represent the velocity of the object. And since the person is walking a steady speed, those arrows being vectors should all be the same length. Now we can tell from our motion diagram that the person is walking a steady speed even if we never saw them, because the displacement between these dots is constant. And so for a constant time, then we have a constant displacement. Now if the person is walking faster, the bucket would be still leaking paint at the same rate, but perhaps at this moving faster, the person would move further, and therefore the dots would be further apart than they were up here. Again, they would be steady distance apart, but further apart than our previous example. And adding the velocity arrows to them, those velocity arrows would also be longer to represent the greater velocity. Now, what if the person was slowing down or speeding up as they ran? Let's say they were speeding up. So maybe they're being chased by a dog. So the dots start out close, indicating slow motion, but they get further and further apart. And so if you saw this track of dots on the ground, you would recognize that that person had been moving faster and faster. And again, we can add our velocity arrows here, making each one longer than before to represent an increase in speed, and that one's off the edge. Now we can put this all together in a more complicated motion, the motion of a person walking a steady pace, slowing down to a stop, resting, and then turning around and speeding up. So here they are, walking a nice steady pace, nicely spaced out, and then they begin to slow down and the dots get closer together. Now let's say they stop for a while. Well, we can't show dots on top of each other, we wouldn't see them. So we just drop down vertically, and that shows that at least on this number line here, the object is not moving. Then it says it turns around and speeds up in a steady pace in the other direction, but slower than before. So again, we want to show them speeding up. But now they end up going a steady speed that's slower than before. And those dots are closer together. And so that would be a motion diagram. You could add the arrows, I won't here, to represent that more complicated motion.